about volumetric strain. So volumetric strain in structure is caused only due to normal stresses. Okay, your shear stresses only causes a distortion of the structure and has no change in volume, or your shear stresses will not contribute in change of the volume. Now we define volumetric strain as what? Change in volume to original volume. Okay, which is like delta V by V. Now here we consider a triaxial stress system. I will show you guys, which is already drawn. Yeah, so you guys can see this is a triaxial stress system. So here there is a sigma x, and then there is a sigma
Me,
y
sir.
in y direction, and then there is a sigma z stress in z direction. Clear?
Hello.
Yeah, Shrestha, you have any doubt or concern?
Yes, sir. I'm afraid I'm not being able to see your
Hello?
screen. I'm not being able to see whatever you're sharing, sir. I can only see the main page of IIT classes.
Yes, Shrestha.
Yes, sir. Can you hear me?
Okay. So is this clear, this three-dimensional stress system? Shiva, it is clear? Sigma x, sigma y, sigma z, and okay. Now guys, you guys know what is my strain in x direction? What is the epsilon x? Anyone? What is the epsilon x value? If I ask, what is my stress in x direction? Anyone can tell what is my stress in x direction? It is what? Delta x dash minus delta x upon delta x. What is the delta x dash? The initial length of this cuboid in x direction is delta x. The final length is what? Delta x dash. So my strain in x direction is what? Final length minus initial length upon initial length. So what is the final length if I write from here? Anyone? It will be 1 plus epsilon x into delta x. Is it clear? Same way, if I want final length in y direction, which is what? 1 plus epsilon y into delta y. Final length in z direction, it is what? 1 plus epsilon z into delta z. Is this clear, guys? Any doubt? Everyone, please. Is this clear?
Sir, we can't see
Or any
anything.
doubt?
Sir, we can't see anything.
No doubt, right? Yeah. Now, guys,
Sir,
what
excuse
is
me,
the?
sir. Can you hear me?
You are not
Hello.
very audible. Yeah. Well, just a moment. Yeah.
Sir, can you hear me now? Is it clear?
I can't hear you actually.
Sir, I'll type then. Okay, fine.
Hello. Yeah. Can you write in chat box?
Hello, sir. Am I audible?
Hello.
Hello, yes, sir. Am I audible, sir?
Yeah, I'm audible, right?
Yes, sir, you are audible. Sir, Shreyas is unable to hear you. That's what he's saying.
Hello.
Hello, yes, sir. Sir, Shreyas is unable to hear you.
No, I can't hear you guys. I'm not able to hear guys today. See, actually, it is not visible to you guys. I think there is a, Shrestha internet issue on your side. Others, yeah, you can try and join again. Yeah, others, you guys can hear me, right?
Yes, sir.
Whatever I have written is visible, right? Yeah, cuboid is there.
Yes, sir.
Okay, so that means if it is the issue with you guys, means the issue on your side. Okay, those who are having poor internet. Okay, so guys, just try to join it again. So for others, I'm audible as well as the screen is visible, right? Yeah, everyone please respond.
Yes, sir. Yes, sir. You are clear, sir.
Okay, perfect, perfect. So is this clear, the changes in length? The final length of cuboid, is it clear to everyone? How I got the final length? See, I know the strain in a particular direction. So from that, I can find the final length in that direction. Now guys, tell me, what is the final volume? It will be delta x dash, delta y dash into delta z dash, right guys? Right guys? Am I right or not? What is the initial volume? It is delta x into delta y into delta z, right? This is my initial volume. Now guys, what I want volumetric strain, right? What I want? Volumetric strain. So what is my volumetric strain? It is E equal to V final minus V initial by V initial. Am I correct? Yes or no, guys? What is the V final? It is delta x dash, delta y dash, delta z dash minus delta x, delta y, delta z upon delta x, delta y, delta z. Now what is the guys delta x dash into delta y dash into delta z dash, guys? It is 1 plus epsilon x into delta x, 1 plus epsilon y into delta y, 1 plus epsilon z into delta z. Yes or no, guys? Is this clear till? This is what my final volume. Yes or no? Now, guys, what I can do, I can expand this. Okay, if I expand this, you'll get like this: 1 plus epsilon x plus epsilon y plus epsilon z plus so on, then into delta x, delta y, delta z. Now tell me guys, it is, what is the so on? The higher order term, right? The higher order term of multiplication. Yes or no, guys?
Yes, sir.
Yes or no? The higher order term of multiplication. Okay. Now what I can do, can I neglect those higher order term? Can I neglect those higher order term in multiplication? Because those terms are very small. Since your strengths are small, So what will be epsilon x into epsilon y? It will be close to 0, right? So if I neglect those terms, so finally my V final is what? 1 plus epsilon x, sorry, plus epsilon y yes. Now this we can substitute here. So what we will finally find? My E equal to so here this and this cancel, this one is cancelled. So finally we find your volumetric strain is summation of your strain in x direction, y direction and z direction. So is it clear to everyone? Is this clear? How my volumetric strain is summation of epsilon x, epsilon y and epsilon z. What is your epsilon x, epsilon y and epsilon z, everyone? What is those? What is those epsilon x, epsilon y and epsilon z? What is those? Normal strains. Exactly. Normal strains in respective x, y and z direction. Okay. Now guys, can anyone tell what is my epsilon x in terms of stresses? You guys know stress strain relationship? Anyone knows strain stress relationship? Anyone? Shruti, Shiva, Sai, or Rayane, Purvika, anyone? What is the strain stress relationship? Anyone?
Hooke's law. Stress is directly proportional to strain.
Yes or no?
Modulus of elasticity.
Strain equal to stress by modulus. But that is only for uniaxial loading, right? When you have sigma x alone, then you can write epsilon x is what? Sigma x by E. But here it is a three-dimensional stress system, right? Shiva, you have seen it's a three-dimensional stress system, right? So what is your epsilon x in this case? Anyone? It is sigma x by E minus nu times sigma y plus sigma z by E. Anyone is aware of this formula? Anyone is aware of this formula?
Yes, sir. Yes, sir.
This is from stress strain relationship or constitutive relation, right? So same way, what is your epsilon y? Is sigma y by E minus nu times sigma x plus sigma z by E. Okay. Same way, what is the epsilon z? Sigma z by E minus nu times sigma x plus sigma y by E. Okay. Now guys, we will substitute this epsilon x, epsilon y and epsilon z in this equation. When you substitute and further simplify, my volumetric strain in terms of stresses is given by this equation. So is this clear to everyone? First, we found what is the volumetric strain, delta V by V, and then volumetric strain in terms of normal strains, and then volumetric strain in terms of normal stresses. Everyone, yes or no? Am I audible? Whatever I have discussed, is it clear?
Yes, sir.
Okay, all right. Yeah. So Vinay, I think 2-3 guys are only responding. Shiva, Vishal. What about others? Yes, Swini, Shruti, or Pranav, Prajwal. Okay, all right. Yeah, so fine. So once you know this, then what is your hydrostatic loading? Anyone? Anyone? What is the hydrostatic loading? Anyone? What is the hydrostatic loading? Can anyone tell what is the hydrostatic loading? You guys have studied fluid mechanics, right? So hydrostatic loading is nothing but pressure loading. Pressure loading. So what is the speciality of hydrostatic loading? Yeah, pressure loading. So in from all the direction, your stresses are same. So in hydrostatic loading or pressure loading, what we know? Your sigma x will be equal to sigma y is equal to sigma z equal to P. If you have outward pressure. Clear? Is this clear? If your pressure is inward, then sigma x equal to sigma y equal to sigma z equal to minus P. Clear? Is this clear? So what is the outward and inward pressure means? What outward pressure will do? Will it increase volume or decrease? Will outward pressure increases volume or decreases volume? Outward pressure will decrease volume. See, if your pressure is outward, will it decrease the volume? It will increase the volume, right? And if your pressure is inward, it will decrease the volume. Okay, so this is about hydrostatic load. Now guys, what I do, I substitute sigma x. If I substitute sigma x equal to sigma y equal to sigma z equal to minus P. Okay, if I substitute this in this equation, what it will become? It will become E equal to minus 3 into 1 minus 2 nu upon E into P. Yes or no, guys? So what minus sign indicate? Screen got stuck, everyone? This, no? For me it is perfectly fine. Okay. I think you guys got, no, it's fine. I'm using two different devices, Mr. Suraj. I'm using two different devices. It is perfectly fine. Okay. Okay. I'm writing in iPad and the audio is from mobile. Okay. Today I have not connected with PC. That's why the initial some hiccups were there. Okay. So just, yeah, now, yeah. Is this screen clear to others? Yeah. So I think it's a localized problem. Okay. So now it is clear. The E in terms of pressure, the volumetric strain in terms of pressure, and why negative sign is there? Why this negative sign? Because we consider the inward pressure. So the inward pressure will decrease the volume. So your volumetric strain is negative. Everyone, yes or no? Right. Okay. Now guys, what is this? You guys understand what this is known as? Anyone can guess what it is known as? E upon 3 into 1 minus 2 nu is known as what? Exactly, bulk modulus. Bulk modulus K, right? Bulk modulus. So what is your volumetric strain, guys, for hydrostatic loading? It is minus P by K. Clear? Bulk modulus of elasticity. Now guys, we will discuss this on further. Few important points. What is those points? Now look here, what we got, K equal to E upon 3 into 1 minus 2. Now anyone knows what is the G value, guys? What is the G? G is what? Young's modulus of rigidity, right? Modulus of rigidity. So what it is? It is E upon 2 into 1 plus nu. Yes or no? Are you guys aware of this? What is the G value? Yes or no? This is what G. Now guys, tell me, can K be negative or G can be negative? Can K be negative or G can be negative? Yes or no? No. Both are cannot be negative, right? Both K and G cannot be negative. Now tell me here, in this equation, if nu is greater than, if nu is greater than 0.5, what will be the value of K? What will be the value of K? Exactly. It will become negative value. So what is the meaning of that? What is the meaning of that? Nu cannot be greater than equal to 0.5. Yes or no? Nu cannot be greater than 0.5. So nu has to be always less than equal to 0.5. What is the nu? Nu is a Poisson's ratio. So is this clear, guys, here? This point? So for any material, the value of nu should be less than equal to 0.5. Now, in this equation, if your nu is less than -1, what will be the G value? If nu is less than -1, what will be the G value? Again, negative, right? That means what? Nu has to greater than equal to -1. Clear? So for any material, nu cannot be less than -1 and nu cannot be greater than 0.5. So the value of nu is always greater than equal to -1, less than equal to 0.5. Clear? Is this clear? How the range of nu comes. So in the nu, the upper limit is decided by bulk modulus of elasticity and the lower limit is decided by modulus of rigidity. So everyone, is this point clear about the value of nu? Yes or no? Why nu cannot be greater than 0.5 or less than -1? See, now if k is negative, suppose Shiva k is negative. Now look here, what is the volumetric strain for inward pressure? What it is? It is E equal to minus P by K. Now if K is negative, so even if you are applying inward pressure, what will be E? What will be E? E will become positive. That means you are putting inward pressure and it is increasing volume. Is it physical? It is physically possible. That's why K cannot be negative. Clear? When E is 0, now tell me, when E is 0, Shiva, when E is 0, anyone? When your volumetric strain is 0? When volumetric strain is 0? Exactly, when K is infinity. When K is infinity, your volumetric strain will be 0. Clear? Everyone, is it clear? Now tell me from this equation, which is what? K is E upon 3 into 1 minus 2 nu. So here for what value of nu K is infinity? Can anyone tell? For what value of nu K is infinity? Exactly 0.5. So it is a gate question. This is a gate question. Now tell me, if K is infinity, then that solid is known as what? When K is infinity, that solid is known as what? Anyone? If K is infinity, the solid is known as what? It is known as perfectly incompressible. Yes, very good, Shiva. It is known as perfectly incompressible solid. Okay, so this is what all about K value and volumetric strain. So it's a simple topic, but many times in GATE they ask the questions, and look into this first question. Let's solve this question and tell me the answer. Everyone tell the answer. Everyone. Others also answer. B is the answer, right? So is this tough question? Is this tough question, guys? So it's very clear, right? The Poisson's ratio for a perfectly incompressible linear elastic material is what? 0.5. Why it is 0.5? Because we know K is 3. K is what? E upon 3 into 1 minus 2 nu. And for perfectly incompressible elastic, K is infinity. When K is infinity, if nu equal to 0. Clear? So what is the answer, everyone? B is the answer. So was this tough question? Was this tough? Were you guys aware of this answer before this class? Anyone were aware before this session? Yes or no? If anyone, so this kind of value addition we do in GATE classes. Clear? So this is how these classes will be useful to you guys. Okay? There will be few things which you will be knowing already, but there will be something which will be extra, which you guys may not aware, and we will try to demonstrate, and it will be useful. Okay, in GATE preparation, and everything will be covered in a systematic way. You guys know, right? Volumetric strain is not a big topic. Yes or no? It's not that big topic, right? Many people will just write formula and will finish. Yes or no? Because at IGC we are not going to promise 2-time completion of syllabus or 3-time. Right or wrong? Yes or no, guys? If you complete every topic in a proper way, is it possible 4 years of engineering? Tell me, guys. 4 years of engineering in 6 months thrice. Tell me, guys, is it possible? You guys, right? You all are mature. So we are not going to promise this kind of thing, okay? In 6 months, we will try 1 time in a best possible way, okay? Okay, fine. So let's move to next question. Yeah. This is one of the GATE question from GATE 2020, guys. It came in GATE 2020 AE paper. Okay. So look into this question, guys. What is given? Read the question. The value of Poisson's ratio at which the shear modulus of an isotropic material is equal to the bulk modulus is. So I told what is the guys shear modulus? G. It is E upon 2 into 1 plus nu. What is the K, guys? It is E upon 3 into 1 minus 2 nu. What is given? Shear modulus is equal to bulk modulus. So what it means? G equal to K. So from here what we get? E upon 2 into 1 plus nu is equal to E upon 3 into 1 minus 2 nu. So what we get from here? 2 plus 2, 2 plus 2 nu is equal to 3 minus 6 nu. Right? So what we get? 1 equal to 8 nu, and from here nu equal to 1 by 8. Everyone, is it clear? Is it tough question? Again, if you know the concepts, it's a very easy question, right? So what is the answer, everyone? Everyone, please, what is the answer? Shruti, Shrestha, Ram Mohan, Rahul, Praveen, Prashant, Pranav, Prajwal, Srikanya, Kishan. What is the answer? Right, clear. So it came for how many marks? I think it came for 1 marks, okay? And it is a cakewalk. Everyone, is it clear? So let's move to next question. So read this question. Let's try. What is given? A cube made of a linear elastic isotropic material is subjected to a uniform hydrostatic pressure of 100 Newton per mm square. Under this load, the volume of cube shrinks by 0.05%. The Young's modulus of the material E equal to 300 gigapascal. The Poisson's ratio of the material is. So guys, can we solve this question? So what is given? The volume is shrinking, means it's a decreasing, and how much? It is 0.05 by 100. So this is what your volumetric strain. So what is the volumetric strain? E equal to minus 0.05 by 100. And we know what is the E? It is minus 3 into 1 minus 2 nu into P by E. Now guys, what is the given? Pressure is given. How much pressure is given? 100 Newton per mm square. What is the E value is given? 300 gigapascal. So substitute what we get, minus 0.05 by 100 is equal to minus 3 into 1 minus 2 nu. What is the pressure? Pressure is 100. What is the E? E is 300 into 10 to the power 3 Newton per mm square. Okay. So from here, guys, solve and find the new value. Everyone, please solve this and tell me the new value. So this 300, this 300 gone, 100. So this 100 is gone. We get from there, this minus is gone. So we get 2 nu is equal to 1 minus 0.5, and then from here, so 2 nu equal to 0.5, so nu equal to 0.2. So what is the answer? Everyone please check. Is this tough question? Kishan, what is the answer? Ninu, what is the answer? One by 4. So is this, again I'm asking, is it tough question? 0.25 Shruti, right? Everyone, was it tough question, Rahul? So these kind of questions are asked in GATE exam. Okay. So in GATE exam, questions will not be tough, but you need to have all the concepts clear, right? You need to know what is volumetric strain. Prashant, what is the answer? So what is the answer, Prashant? 0.4. So everyone, is it clear? Anyone has any doubt in this question? Any doubt, guys? Any doubt in this question, guys? Okay, no problem. So let's move to next question. Yes, guys. So read this question number 4. What is given? A rod is subjected to a uniaxial load within linear elastic. Yes, guys. Am I audible? Yeah, audible, right? Sorry, guys, there was a call. Yeah. So what is given? A rod is subjected. A rod is subjected to a uniaxial load within elastic limit. Okay. When the change in stress is 200 megapascal, the change in strain is 0.001. If the Poisson's ratio of the rod is 0.3, the modulus of rigidity. So guys, if you draw the stress strain curve under linear elastic, it is the linear. So what is your E value, guys? It is delta sigma by delta epsilon. Am I correct? Yes or no? So what is the E value, guys? It is 200 by 0.001. So what it is? 200 gigapascal. Now guys, what is the G value? It is asked modulus of rigidity. It is E upon 2 into 1 plus nu. What is the nu value is given? 0.3. So find out the G value, guys. Find out the G value. Yes, it is 76.9 gigapascal. Everyone else, please find the G value. So are you guys finding interest? Yeah, of course it is same, na? The slope is what? If you take here, what will be the slope? Shiva, it will be delta sigma by delta epsilon, right? Yeah. So good, guys. So you guys are getting interest. Can we solve some more question? See, in my subjects, I will take so many questions. Okay. I'll always take more questions. Okay. Okay. So let's see the next question. If the read the question, guys, what is given? If the Poisson's ratio of an elastic material is 0.4, the ratio of modulus of rigidity to Young's modulus is. So guys, what is the modulus of rigidity? G. It is E upon 2 into 1 plus mu. So what is the G by E? It is 1 upon 2 into 1 plus 0.4. So what it is? It is 1 upon 2.8. So what is the 1.28 means? 10 by 28. Yes, good Shiva. It is 5 by 14. Or 0.3, 0.357, right? Exactly. So everyone please the answer. Everyone please the answer. Everyone please the answer. 0.357. Yes, 0.357. Good guys, 5 by 14. Good. So again, this is one of the gate question. So let's move to next question. Yeah. So it's a theoretical question. Tell me guys, what is the answer? The number of independent elastic constant are required to define the stress-strain relationship for an isotropic elastic solid is independent. The total is 3. Total is 3 usually, in fact more. But see, G equal to what? E upon 2 upon 1 plus mu. So if E is known, mu is known, we can find G, right? We have solved the question. So how many independent guys out of 3? The independent material constants are 2. So everyone, is it clear? Total is 3, 2 is independent, 1 is dependent. So 2 is the answer. It came twice, guys. This question came twice in GATE Aerospace. Okay, twice, not just one. One came in around 2007 or 8, and then recently also came. Clear, guys? Is this clear? How many independent material constant, guys? 2. So let's see next question. Yeah, it's a simple and good question, and we will wind up today's session with this question. Okay, we will wind up today's session with this question. So clear? Read this question, guys. What is given? A thin plate, okay. So guys, read this question. Okay, yeah. A thin plate with Young's modulus 210 gigapascal and Poisson's ratio 0.3 is loaded as shown in the figure. The change in length along the y direction is So anyone guys, how we can solve this question? So what is given here? Sigma xx. What is given? Sigma xx was 240. What is sigma yy? Sorry, sigma xx as 100. What is sigma yy? It is 240. What is the length? X length is given as 100. What is the y length? It is 200. What is the E value? What is the E value is given as 210 gigapascal. What is the new value? 0.3. Now guys, tell me what is the epsilon y for two-dimensional stress system? What is the? Yes, around. I think Vinay, you seems to be correct. So what is the epsilon y? It is sigma y by E minus mu times sigma x by E, right? It is from stress strain relationship. Everyone agree or not? Yes or no? It is from stress strain relationship. Now guys, find first epsilon y guys. Everyone please find epsilon y because E is given, everything is given. So here my epsilon y is what? It is sigma y. So what is the sigma y? It is 240 upon, what is the E value? 210 into 10 to the power 3 minus mu 0.3 into 100 upon 210 into 10 to the power 3. So guys, what is the epsilon y is coming? First tell me what is the epsilon y? It will come as 0.001. Am I correct? Exactly. What is the epsilon y? It is delta y by y. The change in length to original length. So what is asked? The change in length in y direction. So since it is 0.001, so from here change in length in y direction is what? 0.001 into initial length 200. So what is the answer guys? What is the answer? What is the answer? Everyone. 0.2 mm. Clear? So was it tough question? Everyone. It looks tough, but if you know concepts, then again it's a easy question. Was it tough question? If you know stress strain relationship, and then you know what is the basic definition of strain, then it's a easy question. Everyone, all of you guys, Ram Mohan, Praveen, Prashant, Prajwal, Sri Kanya, JB, Vidya. So how was the session guys till now? Was it energetic? Interesting, right? So like this, we study every concepts and we solve the questions. If you guys want, I can solve one more good question. You guys want me to solve one more question? All the concepts questions are simple, interesting, and conceptual. Yeah, okay, let's do one more question. Okay, fine. Let's do one more question. Yeah. So guys, look into this question. It's visible to everyone. So read the question, guys. Okay. So what is given? A square plate of dimensions L by L is subjected to a uniform pressure load P equal to 250 megapascal on its edges as shown in the figure. Assume plane stress conditions. The Young's modulus E equal to 200 gigapascal. Okay. So what you guys are saying? There is a square plate and you can say it's subjected to some hydrostatic loading because it's subjected to biaxial loading. You can say and equal pressure. Yes or no? Okay. So it's a biaxial loading with equal magnitude. Okay. Now this is deforming. Am I audible? There was hello guys, am I audible? Yeah, yeah. There was some connectivity issue. Okay, I think there was a connectivity issue. But quickly we will finish that question. Yeah, we'll just one question, right? So yeah, it is visible, right? So guys, everyone, it is visible, right? Look here. So what I written, what is the epsilon x, guys? It is L minus 2 delta L minus L by L. Everyone agree? what it is? Minus 2 delta by L. Yes or no? Now, here, what is epsilon x? From stress strain relationship, it is sigma x by E minus nu times sigma y by E. Now, what is here given? Sigma x equal to sigma y equal to what given, guys? What it is given? It is equal to what? Minus pressure. Yes or no? Yes or no? Right. So substitute here. So what we get? Minus 1 upon 1 into minus mu P by E. And it is equal to what? Minus 2 delta by L. So this mu got cancelled. So what we get from here? 1 minus nu is equal to what? 2 delta. What is the delta value? 2 into 0.001 upon 2 into, what is the E value? 200. Okay, let me write again, into E by T. So what we get? 2 got cancelled. So 0.001 into 200 into 10 to the power 9 upon 250 into 10 to the power 6. So it is equal to 1 minus mu. Guys, tell? Yeah. No. 9 by 5 cannot be the answer, Chavan. Vinay, can be 9 by 5 answer? Yeah. 0.2 can be the answer. Right. So please check your calculation. So what I get here? 10 to the power 3. So then, so we get 200 by 250. So 200 by 250. So what it is? Okay, let me check the calculation. So 200 by 250. So it's 4 by 5. So from here, mu equal to 1 minus 4 by 5. So which is 1 by 5 is 0.2. Clear, guys? 0.2 is the answer. So 1 minus nu is coming 4 by 5. So nu is 1 minus 4 by 5. So which is nothing but 1 minus 0.8. So 0.2 is the answer. 0.2 is the answer. 0.2. So clear this, guys? Is this clear? Is this question clear to everyone? Everyone? Okay. Now, any doubt or any concern about our classes or anything? So any concern about our, yeah, it's a July 11th. Any other concern? Any other concern, guys?